Okay, this is take two, hopefully with audio, of Solving Inequalities Part 2. Today we're going to look at more complicated linear inequalities and how to solve those with tiles and symbolically. And first, you must sing this song. You can pause the video and sing the song to yourself. And remember, there's always an opportunity to make a rap or a video related to this song and uploading it on Edmodo for us all to see. Okay, we're going to start with these two inequalities, and they're a little different than the ones we've worked in class, so you get another couple of examples. The first one is 2m, 5 negatives, and that is greater than 1. And to solve this inequality with tiles, we can't just subtract the 5 negatives from both sides. So we must add 5 positives to do that. So you can see I've added 5 positives to both sides. And on this side, all of these together become 0, so I can take those away. And over here, I'm going to now have 6 ones. And we want to divide those between the two team captains, just like we did when it was an equation. So we'll divide those up, one for you, one for you, one for you. And our solution to this inequality is that x must be greater than 3. And we can check that by putting in a value for one of these x's in the original problem and see that it is greater than 3. So our original problem was 2m plus 5 is minus 5 is greater than 1. So if I put in a number greater than 3, suppose I put in 5. So we have 2 times 5 minus 5. Is that greater than 1? Well, 2 times 5 is 10. 10 minus 5, is that greater than 1? That's true. 5 is greater than 1, so it checks. Now let's go ahead and solve this symbolically. Pause the video if you need to be able to catch up on your notes. Okay, so if we solve this inequality symbolically, we would do the same thing we did with our tiles, which is add 5 ones to both sides. We have our 0 pair here. We have 6 on this side. We have our variables on one side and all our numbers on the other. The next step is to multiply or divide to get 1m. So to get 1m, we divide both sides by 2. That gives us 1m. Divide this side by 2, and m is greater than 3. Now, since we divided by a positive, we don't have to flip the symbol. So our final answer is m is greater than 3. Notice that it's the same as when we did our problem with our tiles. Okay? Pause the video again if you need some time to take some notes. The next problem, we'll be solving this inequality where we have 2 and 3 negative a's, so that would be like 3 negative x's. And that is going to be less than 7. Okay? Now, in this inequality, if we wanted to solve it, we would say, well, I can just take 2 from this side and take 2 from this side, and it would be balanced. And that's true. We can subtract the same thing from both sides, and it won't change our value. So that's the easy way of isolating our variables on one side. Now we have 3 negative x's, so we're going to divide them up. And we're going to say 1 for you, 1 for you, 1 for you. And then these 2, I need to divide into 3 pieces. And I'm going to take 2 of those thirds and go here, 2 of the thirds go here, and 2 thirds go here. And so we'll have that negative x is less than 1 and 2 thirds. Now the problem is we want to know what a positive x is. So with our tiles, if we wanted to go from red to green, we would just flip it over. When we flipped it over, this would be positive. We would need to flip this as well. And then we would flip these over. And what we end up as our final answer is x is greater than 1 2/3. And so you saw how we flipped our symbol because we were really dividing by negative. Okay? So that's the tile. Write that down, pause the video, and we'll go right back into solving this symbolically and compare. Okay, so let's solve this inequality symbolically now. We're going to do the same thing as we did before. We're going to subtract 2 from both sides so that we can isolate our variable, and we have negative 3a is less than 5. And then we're going to divide by the coefficient on our variable so that we can get 1a. And we'll have to divide this side as well. Now, we divided by a negative, so we must flip the symbol. We'll have a is greater than negative 5/3, which is the same as a being greater than negative 1 2/3. Our same solution as before. So here is an example where we needed to flip our symbol to find a positive a and get our final answer. Okay, and these problems, they're a little more complicated, and what's different about these is that they have variables on both sides. So we're going to solve these using our steps like we did with equations. First, we'll simplify both sides, and they look simple enough. And now we're going to pick a variable side. So I'm going to pick this side to be my c side. That means these 3 c's don't belong over here. To get rid of them, we'll add the opposite to both sides. We'll have a 0 pair. I'll end up with 2c minus 1 is greater than 2. This is our c side, so our negative 1 does not belong. So to get rid of that, I'm going to add the opposite. And I'll have 2c is greater than 3. And I want 1c. To get 1c, we divide by the coefficient on c. We have 1c, divide this side by 2. We'll have c is greater than 1 1/2. Notice that we've solved our inequality by first isolating our variables using addition and subtraction, getting all our numbers on one side, variables on the other, and then using multiplication or division, we can get our one variable solution. Pause the video if necessary to take notes. Now let's look at our next problem. This one, we're definitely going to have to use that first step of simplification because we have to apply the distributive property before we can do anything else. And before I apply the distributive property, I'm actually going to change these subtractions to add the opposites. And so I'll have 3 times x plus 3 times negative 2, which is negative 6, is less than negative 2 times x plus negative 2 times negative 2, which is positive 4. And that's simply solving the, that's simply applying the distributive property and making sure that your signs are right. So double check that you agree with this simplification. Next, we pick our variable side, and I'm going to pick the left side again to be our variable side. So that's where x's are going to be. So we have x's on this side we want to get rid of, so we'll add 2x to both sides. That gets rid of these x's. I'll have 5x plus negative 6 is less than 4. Now I have negative 6 on my x side. I want to get rid of it, so I add the opposite, add 6 to both sides. I'll end up with 5x is less than 10. I want 1x, so I divide by 5 to have 1x, and I'll have x is less than 2 is my final answer. The same steps we've done before. We simplify. In this case, we had to apply the distributive property. We picked an x side or a variable side. We moved things off the non-x side that were x's. We moved the numbers off the x side by adding and subtracting. And then once we had 5x is less than 10, then we divided both sides by 5 to make sure that we get 1x. Of course, next steps in solving inequalities would probably be graphing and checking our solution. But for now, that's basically all the steps that we're using.